Hi, I'm Kai, Chief Architect at Ironclad, and I'm super excited to introduce to you Rivet. Rivet is the open source visual AI programming environment. Rivet was born out of our need at Ironclad to build complex AI agents using chains of LLM prompts. So on the right, you can see Rivet, and on the left, you can see a sample chat application that's connected via remote debugger. So let's dive in. What can you help with? So as you can see, because it's connected via remote debugger, we can actually observe what GPT 3.5 is coming back with as it's coming back with it. This is super helpful for kind of tracing the chain back to where it came from and understanding areas where the agent is failing, areas where it's brittle, and quickly iterating on those areas. We can also do some really cool things around external execution. So because Rivet is executing in our localhost remote environment, we can actually make external calls like calculate. So here we've actually given it the ability to run calculations, 1 plus 1 plus 1 plus 5. And instead of relying on GPT-3 or whatever LLM, we're actually taking the computation ask, passing it into an external call to run it programmatically. And defining these external calls is actually super simple. So here's the code for our host application. We're just importing the Rivet node npm package and then calling run graph on a project that's loaded from a Rivet project file. And then we can actually define external functions dynamically. So here's the calculate function. It doesn't change very much from run to run, but let's imagine you had a AI agent running in an application where user permissions were actually really important. You could actually dynamically define the functions that your AI agent had access to based on the user permissions of the user using the AI agent. So this external functionality that Rivet has is something we're super excited about, and we're using a ton at Ironclad. But let's continue trying to see what Rivet can do. So we've gone ahead and taught this AI agent how to play the game of 24, in which you take 4 numbers and try to combine them with arithmetic operations to come up with the number 24. So here we go. 5 times 5 minus 6 minus 1. I'm pretty sure that's not 24. So let's try and iterate from here. Cool. So we can edit the prompts or tweak them directly in directly in Rivet. So we can see here are some numbers and then a placeholder for numbers, which gets filled in. And then your task is to do blah, blah, blah. Let's add chain of thought reasoning. First, explain your reasoning. Then output the answer in the format below. Cool. So we just saved it, and the updates to the graph actually got loaded dynamically into our host application. So we could either try that again directly from the chat application, or we could click this run button. And that's actually just going to run the application or run this particular subgraph. And so here we go. We have one possible solution, and the answer is 5 plus 5 times 6 minus 1. Again, I'm pretty sure that's not the right answer, but let's actually add some nodes to actually figure that out. So if we recall, we had this external call that could calculate things like that. And now we need to extract this calculation from the answer. So we'll use a regex for that. And let's make answer and then capture group.star. And we can just connect these together. Output 1 goes here, and we can hit save. And again, we can just execute the updated graph. And there was an error calculating. Oh, because it added the equals 50. Let's try again. There we go. So it is 50. So As you can see, we're running external calls directly from Rivet. We are iterating on the prompt. We're still not getting it quite right. So let's kind of end this by switching over to GPT-4 instead of GPT-3 and just seeing if this works. It's going to take a little bit longer this time, but we're here at the end. We could keep forward with GPT 3.5 if we wanted to. We can actually compare the result of the external call to a number using a comparison formula. We can run that into a loop, and we can actually ask the LLM to continue trying until it gets something that's right. So all sorts of things are possible with Rivet. We're excited for you to try it out. It has been game-changing in Ironclad's development of large language models and AI agents. So let us know what you think. Thank you.